In previous section, we defined divergence operator for three coordinate systems, which are rectangular coordinate system, and cylindrical coordinate system, and spherical coordinate system. Today, we take some examples for divergence operator. First example is find divergence d vector when d vector is this. The d vector is described by a rho vector, a pi vector, and a z vector. So d vector is described by cylindrical coordinate. So divergence d vector in cylindrical coordinate is 1 over rho, round over round rho, rho multiply d rho, plus 1 over rho, round over round rho, d pi, plus round over round z, dz. The rho is rho component of d vector. This is rho. This is d rho. To rho z sine square pi is d rho, and d pi is pi component of d vector. This d pi is rho d square sine 2 pi, and dz is z component of d vector. To rho square z sine square pi, dz. So this is 1 over rho, round over round rho, rho multiply 2 rho square sine square pi, plus 1 over rho, and round over this is round pi, round over round pi. D pi is rho g square sine 2 pi, plus rho over rho z, dz is 2 rho square z sine square pi. So this is 2 rho cubic. So this is 1 over rho, and derivative of this term is 6 rho square sine square pi, plus 1 over rho, 1 over rho is 1 over rho, and round over round pi. This is rho d square is constant in point of view pi, so this can be rho g square round over round pi sine 2 pi, plus 2 rho square sine square pi is constant in point of view z, so 2 rho square sine square pi round over round z. We can calculate this. This is 6 rho sine square pi, 6 rho, right? This is 6 rho sine square pi plus d square 2 cosine 2 pi plus 2 rho square sine square pi at rho is 2, pi is 110 degree, and z equal minus 1. So this is this can be, this is 6 multiply 2 sine square 110 degree plus minus 1 square multiply 2 cosine 220 degree plus 2 square sine square 110 degree. This is the answer of this question. This is too low to, no, this is not low square. The low and the low square, and for low, this is cancelled, and this is for sine, and for multiply sine square, for multiply sine square 110 degree, and plus 2 minus 1 square cosine 220 degree, and 2 multiply 2 square sine square 110 degree, approximated 9.0641. This is the answer of this question. The next question is d vector is described by spherical coordinate. So divergence D vector in spherical coordinate is 1 over r square round r square multiply 2r sine theta cosine pi plus 1 over r sine theta round over theta d theta sine theta plus 1 over r sine theta round over pi and d pi. So d, yes, this is the dr. dr is r component of d vector. The r component of d vector is 2r sine theta cosine pi. This is 1 over r square round r square multiply 2r sine theta cosine pi plus 1 over r sine theta round over theta, and d theta is r cosine theta cosine pi, r cosine theta cosine pi sine theta plus 1 over r sine theta and round over pi. D pi is minus r sine pi. So this is 2r cubic. So first term is 1 over r square multiply 6r square sine theta cosine pi plus 1 over r sine theta. This is cosine theta multiply sine theta 1 over 2 sine 2 theta. So this is 1 over 2 r cosine pi multiply cosine 2 multiply cosine 2 theta. This is multiply 2 cosine 2 theta. So it's cancelled, and it's minus this r is cancelled, and cosine pi over sine theta, cosine pi over sine theta, and this r equal 1.5, theta equals 30 degree, and pi equals 50 degree. So this is cancelled. This is a 6 sine 30 degree cosine 50 degree plus this r is also cancelled. So sine 30 degree and cosine 50 degree multiply sine 60 degree cosine 60 degree. This is cosine 60 degree minus cosine pi is 50 degree and sine 30 degree. This is approximated 1.286. This is the answer of this question. And we next we Maxwell's first equation, Gauss's law in point form. We have already known the electric flux and total charge inside the Gaussian surface is divergence D vector multiply delta V. So we divided delta V in both sides. This is Q over delta V equal divergence D vector. And Q over delta V is volume charge density. So divergence D vector is volume charge density. The meaning of divergence is the radiating. This is the radiating D vector. Radiating D vector. Radiating D vector is volume charge density. So D vector is electric flux density. This is the density. So this is the electric flux per unit cubic meter. This is divergence D vector. This is the meaning of divergence. Divergence radiating. So for example, we have a charge Q and there's some Gaussian surface, and this Q radiate electric flux. Here 5 electric flux, So this is 5 is divergence D vector multiply the volume. So divergence D vector is the electric flux quantity per unit meter. This is the meaning of the physical meaning of divergence D vector. So we take some example to find divergence D vector, volume charge density. This is the volume charge density. So we will find volume charge density, and this is described by rectangular coordinate system. So divergence, the volume charge density is the divergence D vector in rectangular coordinate system. This is round dx, round x, plus round dy over round y, plus round dz over round z. Round x, dx is x component of D vector. This is 4xy over z, 4xy over z, plus round over round y, and dy is y component of D vector. This is 2x square over z, 2x square over z, plus round over round z, and dz is d component of D vector, minus 2x square y over g square. The second term is 0 because 2x square over z is constant in point of view y, so this is 0. And derivative of first term is 4y over z. Third term is minus. The denominator is d to the power of 4, and numerator is 2x square y prime. This prime is round over round z. So x d square minus g square prime. This prime is round over round z, 2x square y. The 2x square y is constant in point of view z, so this is constant prime is 0. This is 0. And this is 4y over z minus, denominator is d to the power of 4. The numerator is minus 2z multiply 2x square y, minus minus become plus, and this is 4y over z plus 4x square yz over z to the power of 4. This is the answer of this question. It means volume charge density of this D vector is 4y over z plus 4x square yz over g to the power of 4. The next question is the volume charge density is divergence D vector in cylindrical coordinate, and divergence D vector in cylindrical coordinate is 1 over rho, round over round rho, rho multiply d rho, plus 1 over rho, round over round pi, d pi, plus round over round z, dz. The rho is rho component of D vector. This is z sine pi, d rho. And d pi is pi component of D vector. This is d cosine pi. And dz is z component of D vector. This is rho sine pi, dz. So it becomes 1 over rho, round over round rho, rho multiply d rho is z sine pi, plus 1 over rho, round over round pi, d pi is z cosine pi, plus round over round z, dz is rho sine pi. Rho sine pi is constant in point of view z, so this is, since this is constant, this derivative is 0. And this is 1 over rho, and derivative of this term in respect to rho, and z cosine pi plus 1 over rho, z multiply minus sine pi. This is sine pi. Sine pi, this is 0. So volume charge density of this electric flux density vector is 0. Next question is we will try to find volume charge density. Volume charge density is divergence D vector. So this is volume charge density is divergence D vector in spherical coordinate. The divergence D vector in spherical coordinate is 1 over r square round over round r square multiplied dr plus 1 over r sine theta round over round theta d theta sine theta plus 1 over r sine theta round over round pi d pi. So dr is r component of d vector. This is sine theta sine pi. So this is 1 over r square round over round r square multiply sine theta sine pi plus 1 over r sine theta round over round theta, and d theta is theta component of d vector. This is cosine theta sine pi, cosine theta sine pi sine theta. This cosine theta multiply sine theta is 1 over 2 sine 2 theta plus 1 over r sine theta. D pi is pi component of d vector, is cosine theta round over round pi cosine theta, cosine pi. So we calculate this. This is 1 over r square, derivative r square is 2r sine theta sine pi plus 1 over r sine theta multiplied 1 over 2 sine pi. Derivative of sine 2 pi is sine pi. Derivative of sine 2 theta with respect to theta is multiply 2 cosine 2 theta plus 1 over r sine theta multiply minus sine pi. So we can calculate this, and this is cancelled, and 2 sine theta sine pi over r, this is 2 is cancelled. This is plus sine pi cosine 2 theta over r sine theta minus r sine theta, and numerator is cosine pi sine theta, numerator is sine pi, right? This is a sine pi. So it becomes r sine theta is 2 sine square theta cosine pi plus sine pi. Cosine 2 theta is cosine 제곱 theta minus sine 제곱 theta. This is 1 minus 2 sine square theta. The 1 minus 2 sine square theta minus sine pi. This is cancel and this is cancel, right? So this is 0. So volume charge density of this electric flux density vector is 0. The answer is 0. Today we take some example for divergence D vector in 3 coordinate system, which are rectangular coordinate system, cylindrical coordinate system, and spherical coordinate system. And divergence D vector physical meaning is volume charge density, and we also take some example for volume charge density using divergence D vector. Thanks for listening to this video, and see you next time. Bye bye.